All right, this is question number 1 in the free response section, and let's go ahead and do this. So we've got basically two objects, and they've got their velocity versus time graph, and we're going to do some comparisons. This is actually a good one to practice. So if you remember from a previous video that we did, we're going to be comparing a few things. So first we want to compare the displacement from 0 to 5 seconds. Well, let's remember the displacement is the area underneath the velocity versus time graph. So for A, that's going to be length times width, which is going to be here 4 times 5, and that's going to be 20 meters. Now we do something similar for B, but it's a triangle. That's 1/2 base times height. And when we actually go ahead and solve that, that's going to be 1/2 times the base, which is 5, times the height, which is 8 when we read it off here. And that also gives us 20 meters. So it turns out A and B each have 20 meters displacement. How do we know this? Area under the curve. We know the displacement is the same because areas are equal. Now, we want to know the average velocity from 0 to 5 seconds. I claim that these are equal. Let's talk about why. Well, let's remember that average velocity is going to be the displacement over the time. And for each of these, the displacement is the same. So same displacement means the same area. All right, now continuing for part C, the velocity of each object at 5 seconds, well, let's read it off here. A is going at 4 meters per second, B is going at 0. Therefore, A is bigger. So VA is 4 meters per second, VB is 0. Now, this is supposed to say absolute value of the acceleration at 5 meters per second. B is going to win that one. Let's talk about why. Well, the acceleration of A is 0 because it's flat. The acceleration of B, well, that's going to be the slope of the velocity graph. Slope of the graph gives us A, and that's just going to be, when we do the math, it's going to be the absolute value of -8 over 5. Again, I'm doing a rise over run, so 8 is the rise. We get a rise of 8. We get a run of 5. And when we do that acceleration, it's going to be -8 over 5. And so we end up getting an absolute value of 8 over 5 for our size of the acceleration. So that's it for problem number 1 on the free response.